I'm going to go ahead and make some 38mm risers for the VFR here, the handlebar risers. Because it's just a pain in the neck, literally, to ride. So let's get right to it. Supervising K9 is on duty. Alright, so here is, of course, our stock setup. Sort of stock. I do have one little spacer in here. And that just brings the handlebar, I don't know if you call them clip-ons or clamp-ons. I don't know. I'm going to call them clamp-ons. These clamp-on bars, just to the top surface here. Normally they'd be down about 1/4 inch more. And so I have this one off, as you can see. So you're going to get an idea what I'm looking for here. It's going to be impossible for me to explain it all up front and give you a kind of a synopsis, because I don't really know exactly what I'm going to do. I'm going to kind of work through this. This is our material. It's some 6163 bar stock. It's 2 3/8 diameter. Got it from McMaster Car. And it's good general purpose aluminum for this kind of deal. It's somewhat, it's pretty strong, but it's still easily machinable and not hardened. And it's certainly not ground. I didn't need that precision on it, because we're going to face the outside of this just a little bit to clean it up, because we're going to use just about every bit of the overall diameter of it for the main base of this thing. So now I'm going to calculate out how long it needs to be, and we need to cut, I would say 2 pieces, but this may be a complete fail project, and you won't be seeing this if that's the case, because what's the point? But I'll do it. I'm going to go ahead and just cut off 1 piece at a time, and then we'll try to machine one and then duplicate it on the other. That really isn't the most efficient way to do it. The way to do it would be to cut off 2 pieces and go over to the lathe and just repeat the steps for each one and work each piece all the way through the operations until you get to a different setup where you need to go with a mill or something like that, which we will need to do. But I don't know if I want to waste this piece if I need a longer piece in the future for something if this doesn't work out. So we're just going to start with 1. The overall length is not going to be too hard to figure out, because we already know how long this is. The total height is, we're going to go at 39mm. That's from the top of the triple tree to the cap, to the edge of this cap. I'm not going to the top here, and we're going to discuss this. This has those little Schrader valves in here. I'm not sure exactly what I'm going to do about that yet, but I do have an idea. So for now, we're just going to leave it on because we don't need to have it off, and I'll lose it. So what I say, 39mm, and then the other half is the other length, all right? The height of this is going to be the other side of it. So the total length would be the 39 plus this, which is 32mm. This is 32mm from here to here. So if we do the 39 plus 32 plus a little bit for facing and errors, then that'll be the length that we need. So if we do the 39 and the 32, that'll be the length that we need, plus a little extra meat for facing off, because we're gonna have to do is bring this to final dimension first, I think. See, again, I'm working through this as I go. I'm probably going to leave it a little bit long, because in the shape I'm thinking of, it's not going to be too terribly difficult to reface it down. And if it's a little long, that's good. So I'm just going to add those 2 up and add 4 or 5 mil, and we'll put it on the end, and then we'll cut it off. I almost got it. Okay, folks, after making a ton of chips, that's not them. I threw those away already. I'm going to fast forward and show you what I made, and it's also scrap. This is no good. I had a bunch of machining video and clips that I was going to kind of lead you through on this video, and I'm just going to use them instead as B-roll while I explain it to you, because it would be kind of stupid to go through the steps I made on machining this when it's not what I'm going to end up using, because it's no good. So I'm going to explain how I did it, all right? How I calculated all this stuff. Let's go back over to the bike. Actually, let's go over to DOB, Dad's Old Bench is probably a better place to do this. Turn the light on. All right. So first thing I did was I took that slug, that piece of that piece of aluminum, and we'll talk about the errors I made in that as far as length here and so forth in a minute. I took this piece of aluminum I wanted to make what is basically the same as this with a slit and a bolt and a thread. So this fat section here would be the clamping area. So I made a couple lines here for you. This would be the path of the bolt going through. We put a counter bore in here with a mill, with an end mill, and then drill it for clearance. This would be the slit itself, and then we'd have threads at the other end. So this would clamp this way. Now you can see from this one you have the hole at the top of that slit, which is the relief for that clamp. Well, if I did that, I'd have to put the hole below this shoulder here, because that's another mistake I made here, which I'll cover shortly. You can see the shoulder inside there with the clearance that I need for other features at the top of the fork. Well, there obviously has to be some transition here, because you see how these holes, the bore and the pin, if you will, are concentric. And if I made them the exact same length, you know, as far as the top of the fork and the top of the pin based on this, there would be nothing in between it. And I wanted at least 5 mils. That's a little bit of what the mistake was I made on the overall length. But anyway, if I was going to put a hole in here, for example, and then slit it up to that hole, it's still not going to clamp this, because you still have this top section that's going to be it's going to try to influence that clamping action, and it wouldn't clamp it squarely. All right, it would essentially clamp it at an angle instead of squarely, which is just not going to work. And once I realized that, I had to abandon this particular design. The other problem I made was I bored it out slightly too big, about 5 thou slightly too big. So the bore's no good anyway. I was sneaking up on it, it didn't work. But anyway, this is how I ended up doing it. I took this side first, and what I did was well, let me show you on this side, because this is a little easier to show. I Dykem blued that side and then put this on top and lined it up like that, you know, by eye and by feel. So we have the same thickness essentially from the greatest diameter, greatest thickness of the clamp on to the outer diameter of my stock, and then scribed a line, but it was on this side. I did it on this side. You can see the Dykem here. So then what I did was I put it in the lathe, you know, just the main body of it in the lathe. After I had faced this, you know, I turned this down just for aesthetics mainly, just skimmed it, and then lined up my tool to that scribe line. You can kind of see the scribe line here, and then rotated the chuck until that scribe line was running concentric with the tool, or in line with the tool. So now this is the concentric center. And then what I did was, because it was on this side, I turned this pin. All right, so I had it in the live center, and I calculated the depth, and I turned the pin in the shoulder here. So once I had the pin turned, I was able to turn this over, and then I did the bore. And then once I did the bore, while I was doing the bore rather, I realized the mistake as far as the length goes, and I had to make this short, so there's no way it's going to go down as far as I wanted it to. So right then and there I kind of knew this was scrap, but I kind of kept going, because it's a learning process as we go. So once I bored it over by accident, then I knew it was definitely scrap. So I'm going to show you, again, I'm going to put some B-roll footage in as I'm talking about this, so you get an idea of the machining side of it, rather than go through the entire long thing and then throw it away. Like I said, it'll be kind of frustrating. Let's go back to the bike here. And again, this is a scrap part, but you can see it's pretty loose. That's no good. And it just doesn't go down far enough at all. Now my original reference surface or register surface was going to be the top edge of this fork where the cap is. That's why there's a shoulder upon a shoulder inside there for the clearance for this. Remember, this is off. And I'm going to do something different to try to incorporate these Schrader valves in here. I'll show you that later when we get to that point, if I can do it. But so I have the shoulder on the shoulder in here, and what it just does, it registers up against the top of the fork. So with that, you know, if it would clamp, if I could get it to clamp, that'd probably work, except for the board being too big, this design rather. And then, you know, mill off some extra here and there for more aesthetics because it's so bulky. But it's just not going to work because of that. With a hole there and a slit, it's just not going to work. It's not going to pull it evenly, and it's not going to clamp it evenly. All right, so that's where we're at on this one, and the B-roll machining video that I'm inserting here and there was making this one. So I'm not going to show you a lot on making what is the new part, which I'm going to show you right now. Okay, this is the new part, the new slug. I went and I cut off the remaining pieces, 2 pieces. Luckily I had enough to do 2 pieces in the bandsaw. You saw me do that before. And what I made these was 95 millimeters long because I needed extra space for that transition in, between the bore and the pin. And I realized my mistake on the last part and I wasn't about to duplicate it. So I made these really long. That way I can also put the bore deep enough to where this surface here, this flat surface, registers all the way down to the top of the triple tree where, let's see, there's a nice vacuum spring there because it's a nice fit. It registers right down here to this raised section around where the fork penetrates. All right, so this goes there and it just sits there. Now, instead of doing a clamping thing, what I'm going to end up doing is this. I'm going to look straight down here and show you. That little line down there is the widest portion. I measured it last night and marked it. And what I'm going to end up doing is I'm going to mill away on the bottom all the material except enough to go into this recess right here. So if I pick it up a little bit, you get an idea what I'm talking about. You can see it in there. You see the recess? And this is going to lock this in to prevent it from turning. Then what I'm going to do is, once this feature, the pin feature side is done and it's brought to final length, I'll switch it back over to the scrap piece for this. We're going to take and put a M8 bolt, counterboard, cap bolt, go straight down and drill through the top of the triple tree and put a nut behind it, like a locking nut, Teflon nut. And M8's going to be plenty fine to pull this in. The piece that not this one, but the other piece with the better bore, will not let it go back and forth because it's a tighter fit. And it's not going to rotate because it'll be into this recess here as far as milling the slot for that. Milling the material away to leave a slot, like a key. Essentially, it's a key. Right, so we'll go back to the other piece now. All right, like I said, this is a pretty good fit. Very little movement on this one, so you have to have some clearance. I mean, it won't go on otherwise, so just a little bit, which is good. And again, when I mill this bottom part, we're going to mill away everything except the area or that key area that's going to fit down inside this little recess. So that really is the next thing I believe that I'm going to need to do. Because I don't need to reference off of the back face, I don't think anymore, even when I do the pin. Because when I do the pin, I'm going to be using the ID of, oh, come on off of there. I'm going to use the ID here with the jaws of the chuck for internal bores to chuck it up. And that way I know the pin is concentric with that hole when I turn that. This is the most complicated feature on this thing. The bore, the depth, and milling that key thing that's going to go down in here, that section that goes down in here. So again, this is the most complicated section of it. And so I figured the best way to do this would be to do that first, instead of the other one where I did the pin first. That was dumb. And because of the length, I know I have plenty of meat, about 5-6 mil, that's going to be between the counterbore down, or I should say the face down in the bottom. There is no other step in there, all right? And where the pin starts on the shoulder, which you will see shortly. So that is the plan, and I didn't want to, like I said, I didn't want to go through all that other video when it wasn't the part I was going to use. So I'm just going to use little fragments of it, and then we'll move on from here. First thing I'm going to do is before I do any milling, is I need to lay this out. There's no way to measure it, so I'm going to have to lay it out by eye. And to do that, I need to make sure that my mark on the thickest part is as accurate as possible, which it's slightly off, but not bad. So wherever the needle tops out and starts to drop again is our top. I have it lightly chucked on the inside of that bore. When we go to turn the pin, we'll put some shims in there, like brass or something, to make sure it doesn't damage it. So right there, when the needle stops and then starts to drop out, is most definitely our high spot. Well, I'm not sure what happened. I did hit record and it did not record. I watched it start and it must have shut itself down again. Anyway, you saw those lines I scribed in here. What I did was I used a spring-loaded center punch as a pointer and ran that back and forth to get it square with the center, or in line with the center. And then used a 3/4 inch end mill and hogged this out. What I ended up doing was I had to go back in here though on the lathe, because originally just hogged it out so this area, this key if you will, was extending right up to the edge of the hole. Well, you can't do that because of the feature that's on the top of the fork, that area where this is going to sit on, which is right next to where the fork penetrates. So I put it back in the forge jaw and just quickly dial indicated it in and cut that out. Cut it out! My original cut was only 50 thou for some reason. I must have misread the indicator. I tell you what, I'm doing great today. And then I came back in and did another 100. Did some hand filing on the edges here, which I'll polish up here in a little bit. But I'm pretty satisfied with the way it came out. So let me show you how that articulates with the top of the fork. Alright, so let me see if we can get you in here. We go on top of the fork. That little key is going to fit down that recessed area. I want to call it a slot, but it's not. And it does. Now I do have a little bit of movement there. I cut it a little too much, but you know, that's a radius and it's not machined, so it's very difficult to get an accurate width on it. But all it is to make sure it doesn't ultimately turn. And when this thing's bolted in, when it has a bolt down this side into the top of the triple tree, it's not going to allow it to turn anyway. This is kind of a double safety anyway. So I put a 1.5 thou here feeler gauge, and it just barely tries to start. But when I lift it up and put it underneath, it grabs it. But I can feel for sure that it is seating on that feature. That's what I'm talking about. That's why we had to do the relief right there, because of this part that sticks out in there. I kind of forgot about that. But I do like the way this thing fits. And I know the hole will end up coming out about halfway through that key when I plunge this hole through for bolting it. But that doesn't matter because it's hitting on both surfaces. It's hitting on that round machined area where the relief cut is, and it's also hitting on the key itself. So it's not going to cock it or influence it in any way that I can imagine. So yeah, it feels really good. And it is freaking nice and solid now that it's sitting down all the way. And yeah, a lot of machining, but I'm real happy with the outcome right now. So the next step is, and I will film a little of this, is we'll put her in the 3-jaw. Use the inside jaws. We'll put a center in, because it'll be off to the side, of course, because it'll be concentric with the inside hole. Figure out our depth, or length of cut rather, based on the depth of that bore, plus 5 mil or so. And then we'll go ahead and turn this down, and hopefully we have enough meat for the thickness of that of the clamp on here, this part. But I'm pretty sure we do, because I measured it last night and it did. But that was before I milled it, so that of course brings it up a little bit. So let's go ahead and do that. I'll whittle this back, and when we get down to close to finish, we'll come back. Read 1.460, well, actually 64.5, but let's round it up, 65. We got basically 10 thou to go because we're doing 1.455, which is the exact size of the top of the fork. We know that the clamp-on fits that, so we're going to make this exactly that. So we definitely can't blow this one, otherwise it scraps the part. So it's really hot right now. Got to let it cool, and then we'll take some finish passes, get it within a couple of thou, and then bring it in, hopefully, if I can find some, with some memory or a file. Maybe a file. File's probably the best way to do it. But we'll bring the last couple of thou in by hand. 456 on the nose. So that gets us exactly where we want to be. Let's send it. Might be another half thou out of it. That's okay though. Yeah, 456.5 over here. Actually, that's the same, 456.5. That'll work. Now we'll bring her in with a file. Right on the nose, 455. Yeah, a couple of tenths, maybe 2 tenths over, so that's close enough. I want to hit it with some Scotch-Brite now. We'll clean it up, and then off camera I'm going to do a chamfer. But I'll show you one thing I'm going to do is I'm going to cut a internal radius at the juncture of this face and the what do you want to call it, the pin. Not only to make sure there's clearance for that thing to sit all the way down, but to stress relieve this sharp edge. I ground a tool. I got to switch over to the lantern tool post for it though, so I'm going to set that up. But before I do that, I'll cut the 45 here. I can't do this until I chuck the OD here because it's out of round, obviously. So I'll do this off camera, but I'll show you that part. That'll do it. Can't complain about that. Here's the clamp on. Should just start to go on. Yep, just like that. You see, it'll definitely go on. It just needs to be helped a little bit. You can always spread that out, a little bit too, but it's the exact same size as what it goes on normally, so we're not going to worry about that. Alright, so we're going to keep this right where it's at. We try to mess with it anymore, we're going to screw it up. Now it's just a matter of turning down the OD just for aesthetics. We're going to clean it up. This is going to be easier in the 4-jaw ultimately. The setup's a little longer, but I can turn the whole thing in one. I only need to take it down a little bit more than what this surface is. It's just a little bit more work, but so we'll indicate the uncut area in because that's fine. And it's just like anything else. I go from jaw to jaw and then from jaw to jaw, so you kind of make a plus sign and work on only one axis at a time, otherwise it gets really confusing. Can't chamfer this with a tool, so I'll do this by hand off camera. I can do this one right here though. I'll go ahead and do that off camera, and then we'll do a test fit and we'll show you how it looks with the clamp on, the handlebar on. Okay, so we'll try to get you down here so you can see the difference in the height. Pretty significantly higher. This is probably the best angle to look at. When you look at the top of that one and the top of the other one's way down there. So now I know we're going to have interference between the windshield and the the clutch master cylinder. I expected that. I'm not 100% sure what I'm going to do about it besides modifying the windscreen. This is an aftermarket windscreen anyway. First thing I'll do is go online and verify this isn't some rare thing or something. And I doubt it is. I don't know who the manufacturer is. A lot of times it's stamped, or not stamped, but like screen printed on it or printed on it in some way. But I don't see anything on here. It could be just some, I don't know. Clearly not stock. But I don't want to modify something that's really, crazy rare or something, which I doubt. So I can always get another windscreen for it and then modify it and keep this one for, posterity or otherwise. So, see, the thing is, I know it's kind of aggressive modifying a windscreen just for a riser, but the thing is, like I said, I can hardly ride this bike with my neck issues. So getting these bars way up high is the solution. Now I know I need to extend the clutch master cylinder hose and the front brake hose, at least the short one that goes down to the distribution block. The wiring, on the other hand, is going to be a difficulty. This wiring is already pretty tight, and it's really, really close to not fitting, so I'll have to figure out what I'm going to do about that. Take this fuse block cover off and see if there's any length in there. I would really hate to modify and extend the wires, so it's one of these other things where if I went online on eBay and I picked up another set of these, no matter what the condition is, at least I can use the same color wires and just extend them a little bit, or just swap them out if they're better. Save these and then put the other ones on, or combination of parts, whatever. Because this side's going to be the same challenge, I'm sure. We do have wiring coming up to this one for the start and the stop switch, and of course your brake switch, and there's one for the clutch. But that should be right on the master cylinder, so should that. So the brake switch shouldn't be an issue, I wouldn't think, because it's tied to the same harness. Extend the harness and that comes up with it. But this definitely works. Now what I'm going to do for the air valve, remember this is straight down. It's concentric with the fork. What I'm going to do with the air valve is I'm going to get some extensions. This will be drilled out, and there'll be appropriate size hole. You get those like truck Schrader valve extensions, and shove it in from the bottom, because the bottom generally is bigger for when it goes over the Schrader. I do have clearance already cut in there. Put those on, slip it down, so get a Schrader that just sticks up from the top, and then put these little caps back on. I can figure out something, and then you can still use that. So I didn't want to eliminate that either, but I would. I don't use it now hardly. I may put a few PSI in with my little hand pump, but that's about it. So yeah, we got pretty aggressive raise here, or rise, and there's going to need to be some other work done to make it work properly. Right now I have this pin right here. I don't know if you can see it. It's not a pin yet, or now rather. It's just a hole with a thread. That's where that cap bolt goes, which acts like a pin that locks it into there normally, right? You can see it's partially blocked by the riser, and that's what I wanted. I wanted some material in there, so what we could do is probably about half the hole. We'll plunge in there from the top with an end mill to make a relief for that just fits that cap bolt. Put the cap bolt in, and it locks this from rotating to the riser. And then of course the riser has that, and we'll have a cap bolt which will be underneath here because it'll be below the surface, that goes down through the triple tree. I still haven't figured out what I'm going to do with this, because I don't think we're going to be able to fit a nut. So I may just tap into this. It is pretty thick. And then if we can just tap it in, I'll use a fine thread cap bolt of the appropriate length. Or I can make a special nut, like a special retainer nut out of steel that makes this radius underneath. You can't really see what I'm saying, but underneath there's a radius similar to this. All right? And then I can just put that underneath there. Maybe make it out of some stainless so it don't rust. And then when we put the hole in, that'll capture the cap bolt. There's a number of things I can do, but either way I can start by just threading it. If it doesn't look right, I'll drill it out for clearance and then do that. But it works. I think these are going to be bomb-proof. We're going to cut all this extra crap out. So from here to there, it'll be straight. And then from there to there, it'll be straight as well. We don't need that in there, and it just looks like crap. So that's the next thing I'm going to do off camera. I'm not going to do any more in this job on camera. And then I think I'll just put this these video files away until I get it totally done, and then I'll show you the total finished product. All right, folks, I changed my mind yet again. Go figure. Surprise, surprise. Let me go out to my truck and get my surprise look. What I did was I did split this and did put a relief hole in it, and I drilled and tapped for an M8 125 cap bolt, and this does clamp down pretty well, but honestly, I haven't even tried it, and I'm not going to. I had to put this back together anyway because it's hard to move it around with one bar, and there's a couple of reasons why. Number one, I don't really like the way this thing fails to register into that relief down in there, and plus that's just not a good surface to register to anyway. Number two, it's too high. We're talking about 50 mil, I think I measured it at, 50 millimeter rise in the bars. That's just too high. I was looking for more like 35, 38, something like that. Hell, I'd take 25 if I could get it. So that's just too high. Number three, I'm not going to trust it. It's beefy enough for certain, and don't believe it would come off, but we'd be relying on that one bolt. Of course, we're relying on one bolt with this one too, but there's supposed to be two spring clips. This is supposed to go lower. I put these like 1/4 inch spacers and brought it up to the flush there. Normally these things go all the way down. There's a spring clip that prevents this from coming up, or there's a little groove machined into the top of this fork tube. So right now I'm kind of set up, not necessarily the safest way, but these things are not going to go anywhere. But you know, this one probably wouldn't either, but I just could not bring myself to the concept of drilling a hole through the triple tree top here and then bolting it through like I was describing earlier. You know, these things are just impossible to find. If I didn't like it, or I don't know, I didn't want to put holes in it, so I said I'm not doing that. And I don't think I'm doing this, but you know, it was a fun project to work on, try it out, try machining it and see what happens. So essentially, I got to do something with this. I got to raise them up somehow. So there's two other options. One is the better of the two. Let me discuss those briefly with you. This is the cap that goes here. I got this on Fleabay and it was not cheap, but I needed to measure up the thread pitch and the thread diameter. And taking one of these out to do that is a real prick, even with the weight off of the front of the bike, like jacking it up. And then, you know, taking that off, trying to get it back on while the forks are in situ is a real pain in the ass. So I got one of these on Fleabay, brand new. I mic'd it up. And it's kind of an odd duck size-wise. The thread pitch is 1.5 mil, but the overall ID comes up to be like a 33.67 or something millimeter, and I thought it would be like more like 33.9 something. Because sometimes when I do imperial to metric conversions, because I don't have any imperial precision any metric precision measuring tools. It'll come up like on the calculator 30, let's say it's 40, it'll be like 39.9 something. That's 40 mil. This is too far away from that to say it's 34 mil in my opinion. It might be, but I don't know. The pitch is definitely 1.5, that's standard. But the OD, or the major diameter rather, I think it's custom for these forks. So I don't think spending 100, I think I looked up an M34 by 1.5 dies like 136 bucks. It ain't worth spending that to try to make one of these, because essentially what I'm getting to is, if you took the bottom part of this, the thread part, and the top part of this, and essentially made it longer, let's say, you know, 40 mil longer or so, so you put the hex on the top and put the threads on the bottom, we can make extensions that bring this up. And as long as we do it with great precision, they'll be nice and concentric. So even if we wanted to split the difference, put half the clamp on the steel, half the clamp on the aluminum, that'd probably work. But I can't do it on that lathe. There's just no way to do it. And plus, I can't single point any threads on that. It's too sloppy. And I certainly can't do metric. I did try figuring it out. It ain't going to work. Which, you know, leads me to the next point is I really need to replace that. That lathe needs to go. I need to upgrade. I'd like to get a precision Matthews lathe like Quinn has on Blondie Hacks. Can't talk today. Something like that would be nice, but they're very expensive, so I'm working on that idea. But anyway, if I could single point thread this, I would try it. I'd make some about yay long, and at least make the thread part. And at that point I can disassemble this, try screwing it in and see how it works. But it's not safe. It's not really the safest thing. Because let's say I brought it up to the top. So to the top edge of this currently is, right? And so I have extensions up there. That's a lot of stress point for that much threads. I don't think I can go too much deeper. I don't remember how far the threads go down inside the tube. So let's say it's that thick. That's a lot of stress point for that little amount of thread as far as the height of the thread goes. And if I made it out of steel maybe, but you know, then we're really getting into some machining stuff there, because I can't do it with this stuff. And like I said, I'd have to spend $5 grand on a lathe to make a you know, $200 part. So basically I could do that, probably figure it out, or farm it out, you know, machine the blanks and then farm it out and have somebody do the threads. Send this with them. They can use just use the thread wires and mic across and then just duplicate it, because I don't have a nut or something to send them. I can't send them a fork tube. And speaking of fork tubes, I think that's the best way to do this. I'm going to reach out to Frank's Forks and see if they can make me or find me, or otherwise maybe they have them in stock, 37mm forks that'll fit this these you know, fork tubes, or the fork bottoms, that are like 40 or 50 mil longer. Because the regular you know, commercially available, not extensions but risers, are not really risers, they're spacers. And so what you have to do is you have to penetrate the fork through, which lowers your bike down, which I don't want to do. I like the way it sits right now. And so then you just put spacers, and this essentially artificially brings it up. But I can make those. So if we had longer fork tubes, that's something I can definitely machine, even on that lathe over there. Make something that fits nice and snug, or just a precision fit over the existing longer fork tube. Machine the locks in that go down inside that little space down in here where it kind of locks it in to keep it from turning, and do it on both sides so it captures the one from the clamp-on side, and be done with it. So I think that's the direction I'm going to go in, because it's the safest way to go. And if I can't do that, then I'm probably just going to have to abort this whole project, unfortunately. But I don't know. I'm still thinking about it. Fail? Not necessarily. It's not a fail. Anytime I learn something from fabrication or machining, it's a win. Because I learned that this would probably work, but it's not the best option. And it was fun doing it. It was fun learning some stuff, and you know, using a lathe, using the mill, and coming up with a concept, and then making it, you know, reality. I don't use CAD because I don't have it, and I really don't want to learn it. I probably should, but I'm not going to. I don't work that way. I don't put fancy drawings up on my channel like other creators do to, you know, make myself look really smart. So I'd rather work off the seat of my pants and kind of, you know, go through it, and I don't need a trigonometry calculator like other creators do to figure out different things. I like to use T&A, I mean trial and error, and go through it that way, which is what I did. Now, it's not necessarily the best concept, but like I said, it would probably work. But the best concept, I think the best idea, is just getting longer steel, you know, regular metal fork tubes, longer fork tubes themselves. Although I really like to try to machine the extensions with that thread and that pitch, and mill the hex on it and so forth. I can even insert a Schrader valve. I looked online, and you can buy Schrader valve taps. So I could do you know, drill or ream or whatever, you know, the hole for it, and then tap a Schrader valve thread in there and get that working. But it's just not going to work, not in this configuration. So yeah. All right, so if you want to see more on this stuff, and perhaps a lathe upgrade in the future after I sell it to the boss, you know what to do. You need to stick around. So we'll catch you on next video.